Hello guys, welcome to Codenzyme. Today we are going to learn about the Euclid extended algorithm. The first thing that I'm going to tell you is what kind of questions you will be able to solve using this algorithm. So number one, given any arbitrary two numbers a and b, you will be able to find the GCD of a and b, and I will call it G in this whole video. And not only this, you will also be able to find the solution of the equation ax plus by is equal to g, where g is the GCD and x and y are integers, and hence the name is given extended. And number two, the linear Diophantine algorithm is based on this Euclid extended algorithm. So if you want to learn it, you will need to have the knowledge of this one first. So without further ado, let's get started. I will talk about the core ideas now. So, idea number one, if you remember from the previous video, a comma b was changed to b comma a mod b. And in the last iteration, if we keep doing this, at the last iteration, a became g and b was 0, right? So, if is g and b is 0, then what will be the solution of the equation? The equation will be reduced to gx plus 0y is equal to g. And if we solve it, we can see that x is 1, and let's take for now y is equal to 0. This is the first idea behind the Euclid extended algorithm. And let's talk about idea number two. So, idea number two, we know that a comma b changed to b comma a mod b. Given the solution, if we already know some values x1 and y1, which is the solution of bx plus a mod b y is equal to g. This is the solution, so let me write it like this. So if we know the solution of this equation bx1 plus a mod by1 equal to g, then somehow we need to calculate the solution of ax plus by is equal to g. So we are going in reverse order. Like a comma b was changed to b comma a mod b, and now we are going to from b comma a mod b, the solution of x1 comma y1. We are backtracking. We are going in reverse order till we reach a and b, and we are finding the solution of x comma y. So let's quickly calculate it, and we are going to use one formula, that is we can represent a mod b as a minus GIF, floor of a upon b times b times b. And let's take an example. For example, if a is 13 and b is 6, we can see that this will become 13 minus floor of 6 by 13, which is 2 point something. So this will be only 2 times 6, which is equal to 1. And so this works. And if we substitute this here, we will get g is equal to bx1 plus a ay1 minus a upon b floor times by1, right? And if we take a b and a common, we will get ay1 plus b common. Then we have x1 minus floor of a upon b times y1, right? And our original equation was g is equal to ax plus by. Now, if we compare the coefficients, for example, we see that the last coefficient is equal, so we can compare the coefficients, this and this. So from here we get a recursive solution, that is x is equal to y1, and my y becomes x1 minus floor of a upon b y1. we start from 1 comma 0, and we will recursively traverse from values to values till we obtain to the final. We have g comma 0, then we have some b comma a mod b, and then finally we will reach a comma b sideways, and we will also reach our x1 comma, from x1 comma y1 we will reach the original values x and y. This is the idea number 2, and now we just need to code this recursively to find the solution of x and y. So let's get to the coding part, and from this video I will show codes of both C++ and Python. Let's see Python code first. So I will create a new file, extended gcd.py. Let me call my function extended gcd, and it will take two arguments, a and b, and we want this function to return both gcd. It will return both gcd and values of x and y, right? So the first is the base case. If was 0, then I have to return a, 1 and 0. Here 1 is the value of x and 0 is the value of y. So I need g, x1 and y1, right? So g, x1 and y1 is the value of extended in gcd b comma a mod b, and from this equation we have x is equal to y1. So I will make another variable, x is equal to y1, and y1 y is equal to x1 minus floor of a upon b into y1. So x1 minus floor. Floor we can use mat.floor also, but or we can simply convert it into int in Python, right? So int a upon b times y, y1, and now I'm going to return the gcd, the value of x and the value of y. So let's see if this function works. So print extended gcd, and let's take two prime numbers. Let's take two prime numbers. So for example, if we have two prime numbers, for example, if we take a as 5 and b as 3, both these are prime, therefore their gcd will be 1. So if we have equation 5x plus 3y is equal to 1, my solution should be x equal to -1 and y is equal to 2. 6 minus 5 is 1. Let's see if this function returns the same thing, and if it does, it is the correct function, right? So I will pass 3 and 5 here, and it returns the gcd 1, the value of x and the value of y. Let me switch these two numbers and check if it works. So yes, it gives us the correct output. So now that we know how to code in Python, let's also see the code in C++. My function, I will name it extended Euclid, and it will take 4 arguments, int a, int b, and I will also take the values of x and y here, because we cannot return multiple values in C++ like we can in Python. So int and x, comma int and y, and I will just do what I did last time. So if b is equal to 0, we will do x equals 1, y equals 0, and return. Okay. And if it is not 0, then I will have to calculate to the gcd, and g is equal to extended Euclid a b comma a mod b, and I will pass two integers, int x1 and y1. So I will pass both of these here, x1 comma y1, and once these are calculated, I can compute the values of these x and y here. So x will be equal to y1 from that formula, and y will be equal to x1 minus a upon b times y1, and then I will simply return a g. So my function is returning the GCD while also computing the values of x and y, the pointers. So let's test it. I will put a equal to 5 and b equal to 3, and I will also take values of x and y. Now I will calculate int g is equal to standard Euclid 5 a b x y. Now all these values should be calculated. So I will just print them. Print g the space. Then I will print x space finally y. Let's see if this gives us the correct output. That is -1, 2. Giving some error. That should be y1. Let's run the code. And so yes, it gives us the correct output. So this is it, guys. I hope you liked this video. If you learned something new, kindly like, share and subscribe to my channel.